Hello viewers, in my previous video I have shown sums of 12b and today I am going to start sums of 12c. Here the question is, a square OABC is inscribed in a quadrant OPBQ of a circle as shown in the figure. If OA equals to 14 cm, find the area of the shaded region. So this is the figure. So as you can see, OPBQ, this is the quadrant, that is 1/4 of a circle, and inside this quadrant one square is inscribed. OABC is the square. Here it is given OA is 14 cm and we are to find the area of the shaded region, this part and this part. Area of these two parts we are to calculate. I hope question is clear. In case of square OABC, each side is 14 cm. It is given in the question. In case of quadrant POQB, that quadrant, here radius is not given in the question. And we are to find the area of the shaded region. Without knowing the radius of the quadrant, it's not possible to find the area of the shaded region. So first of all, we are going to calculate the radius of the quadrant. For this, in this right angle triangle OAB, since this angle is 90 degree, so this is a right angle triangle, so we can use Pythagoras theorem. So in this triangle OAB, OB square equal to OA square plus AB square, because OB is the hypotenuse. So we can write, in case of square OABC, each side is 14 cm. In case of quadrant POQB, radius is to be calculated. And what we have to find in this question, we have to find the area of the shaded region. Now in triangle OAB, just because this is 90, so OB is the hypotenuse, so OB square is OA square plus AB square. Now OB square equals to OA, we know it is 14, AB also 14 because it is a square, and in a square all the sides are equal. So OB square is 14 square plus 14 square. So OB square is 2 times 14 square, we can write 2 into 14 square. So OB equals to root over 2 into 14 square. The square and root can be cancelled, so you got 14 root over 2 centimeter. That means since OB is 14 root 2, that means radius of the quadrant is 14 root 2 centimeter. So we have calculated radius. Now we have to find the area of the shaded region, and for this what we will do, we will subtract the area of the square from the area of the quadrant. Now area of the shaded region is area of the quadrant minus area of the square. Now area of the quadrant is 1/4 of a circle, and we know area of a circle is pi r square, so it will be pi r square by 4 minus area of the square. Since we have considered each side of the square to be OA, so we can say OA square. Therefore area of the shaded part will be area of the quadrant minus area of the square. For quadrant it will be pi r square by 4, and for the square it is side square, or we can write OA square, and it is given OA is 14 here. So here we can write pi r square by 4 minus OA square. Here it is pi, instead of r we can write 14 root 2, so 14 root 2 square by 4 minus OA square. Each side of the square is 14, so it will be 14 square. Now pi 14 square is 196, root 2 square is 2, divided by, here it is 4, so it will remain 4 minus 14 into 14, 196. Now these 2 and 4 can be cancelled, we got 2 here. Now we are replacing pi with 22 by 7 into 196 by 2 minus 196. Now if I cancel 7 and 196, then 7 2 ja 14, 56, 7 8 ja 56. So that means on cancelling 196 by 7, we got 28 here, and 22 and 2 can be cancelled, we got 11. So we are left with 11 from this part. From here 28 minus 196. 11 into 28 is 306 minus 196. If we subtract, we are going to get 112 centimeter square. That means 112 centimeter square is the area of the shaded region. So it's quite a simple sum. What we have done first, from this triangle OAB, using Pythagoras theorem, we got OB, which is the radius of the circle or the quadrant you can say. Now to find the area of the shaded region, we have subtracted area of the square from the area of the quadrant. And area of the quadrant is pi r square by 4 because it is 1/4 of a circle. Just imagine, suppose this is the circle and this part is the quadrant. For full circle, it is pi r square. For the quadrant, it will be pi r square by 4. So pi r square by 4 minus area of the square will give the area of the shaded region. I hope this sum is clear. Let me explain the next sum, that is question number 2. Now in question 2, in the figure AOBCA represents the quadrant of a circle. AOBCA represents quadrant of a circle of radius 3.5 centimeter. Calculate the area of the shaded part. That means we have to find the area of this part. And here we have to consider pi to be 22/7. Now in case of quadrant of circle, here radius is given as 3.5 centimeter. And in case of triangle AOB, here AO equals to BO equals to 3.5 centimeter. Now what we have to do, we have to find the area of the shaded region. For this we are going to subtract area of the triangle from the area of the quadrant. And area of the quadrant, which is 1/4 of a circle, it will be pi r square by 4 minus area of the triangle AOB is half into base into height, that is half into AO into BO. So area of the quadrant is pi r square by 4 minus half OA into BO. Now pi is 22/7. Radius is 3.5 into 3.5 divided by 4 minus half 3.5 into 3.5. Now 22 and 4 can be cancelled with 2. So here we got 2, here we got 11. So we are left with 11 into 3.5 into 3.5 divided by 7 into 2 minus half 3.5 into 3.5. Now 3.5 into 3.5 by 2, here also 3.5 into 3.5 by 2 can be taken common. So here I have taken common 3.5 into 3.5 by 2. So from this part we are left with 11/7 because this part I have taken common minus this whole thing I have taken common. So we are left with 1. Now 3.5 into 3.5, it will give 12.25 divided by 2. And from here if I take LCM 7, because 1 means it is 1 divided by 1. LCM of 7 and 1 is 7. 7 divided by 7, 1. 1 into 11, 11 minus 7 divided by 1, 7. 7 1 ja 7. So here we are left with 12.25 by 2 into 11 minus 7 is 4 by 7. Clear? So 12.25 by 2 here and 11 minus 7 is 4. 4 by 7 I have written here. Now 2 and 4 can be cancelled. We got 2. And if I cancel 12.25 by 7, we are left with 1.75. So after cancellation, we got 1.75. It is 1.75. So 1.75 into 2 and 1.75 into 2 is 3.50 centimeter square. That means area of the shaded part is 3.5 centimeter square. So in this figure, area of this part is 3.5 centimeter square. Clear? So what we have done, we have subtracted the area of the triangle from the area of the quadrant to find the area of the shaded region. I hope sum is clear. Now let me discuss question number 3. In question number 3 it is given in the figure ABCD represents a flower bed. If OA equals to 21 meter and OC equals to 14 meter, find the area of the flower bed. So this is the flower bed and here it is given OA from here to here, this length is 21 and OC is 14 meter and we have to find the area of this flower bed. Here you can see two quadrants are there. This is smaller quadrant and this one is bigger quadrant. So in case of outer quadrant, that is AOB, here radius is 21 meter. That means if I consider AOB, the bigger quadrant, radius is 21 meter. And in case of smaller quadrant, that is COD, radius is 14 meter. Now what we have to find? We have to find the area of the flower bed. For this what we have to do? We have to subtract area of the smaller quadrant from the area of the bigger quadrant. And as I told you, quadrant is nothing but 1/4 of a circle. So area of the flower bed is area of the outer quadrant minus area of the inner quadrant. For outer quadrant, area is pi r square by 4, and for the inner one pi small r square by 4, because each quadrant is 1/4 of a circle, so we have to divide the area of a circle by 4. From here I have taken pi by 4 common, so we are left with r square minus small r square. Now pi can be replaced by 22 by 7 into, since it is divided by 4, we can write 1 by 4 into capital R is 21, small r is 14, so it will be 21 square minus 14 square. So if I cancel 4 and 22 by 2, here we got 2, here we got 11, so it is 11, here it will be 2, so 11, 7 2 is 14, 21 square is 441 and 14 square is 196. So 11 by 14 into 441 minus 196, it will be 245. Now if I cancel 14 and 245 by 7, here it will be 2 and here it will be 35. Clear? So we are left with 11 into 35 divided by 2. 11 into 35, it will be 385 divided by 2, and if I cancel I am going to get 192.5. That means 192.5 meter square is the area of the flower bed. So what we have done, to find the area of the flower bed, we have to subtract the area of the smaller quadrant from the area of the bigger quadrant. So it's a simple sum, just this formula you have to remember, otherwise sum is quite simple. I hope sum is clear, and now I'll discuss question number 4. In question number 4 it is given ABC is a right angle triangle right angled at A. Semicircles are drawn on AB. This is one semicircle. On AC, this is another semicircle, and on BC, that means this is the third semicircle. Clear? On AB I have drawn one semicircle, on AC I have drawn another semicircle, and on BC the third semicircle is drawn. It is also given that AB equals to 3 cm, AC equals to 4 cm, and we are to find the area of the shaded region. Now in this sum we are to find the area of the shaded region. Now in triangle ABC, angle BAC equals to 90 degree. Since this one is 90, so BC is the hypotenuse. So since BC is not given in the question, using Pythagoras theorem we can calculate BC. So what we will do, we can write here BC square equal to AB square plus AC square. In this triangle it is the hypotenuse, so using Pythagoras theorem it will be BC square is AB square plus AC square. Now BC square equals to 3 square plus 4 square, and here 3 square is 9, 4 square is 16, 16 plus 9 25, so BC will be root over 25, that is 5 cm. That means this length B to C, this length is 5 cm. So this one is 3, this one is 4, and this one is 5. Now in case of biggest semicircle, which is drawn by taking BC as diameter, so this semicircle you can see here diameter is 5. So in case of biggest semicircle, diameter BC equals to 5. This one is 5, we have calculated by using Pythagoras theorem, and since this is 5, so its radius will be half of it, so radius R1 equals to 5 by 2 cm. In case of second largest semicircle, by taking AC as diameter, another semicircle is drawn. We have considered R2 equals to 2 cm, and in case of smallest semicircle, by taking AB as diameter, here diameter is 3, so radius will be 3 by 2. So we have taken, in case of smallest semicircle, diameter is 3, therefore radius is R3, which is 3 by 2 cm. Now to find the area of the shaded region, what we can do, we can add the area of the triangle plus area of this semicircle plus area of this semicircle, and from that if I subtract area of the biggest semicircle, then we are going to get area of the shaded region. So now to find the area of the shaded region, that is this part and this part, what we can do, we can take area of the triangle ABC plus area of the second largest semicircle, this part, then area of the smallest semicircle, that is this part, and from this if I subtract the area of the largest semicircle, then we are going to get the area of the shaded region. That's why I have written area of the shaded region is area of triangle ABC plus area of the second largest semicircle, that is this part, plus area of the smallest semicircle, that is this part, and from this we are going to subtract this. So area of the largest semicircle is to be subtracted from this. Area of the triangle ABC, it is half into base into height. So in this triangle ABC, area is half into 3 into 4 because this is the right angle. So this is base, this is height. So it will be half into 3 into 4 plus area of the second largest semicircle. This is the second largest semicircle. Here diameter is 4. So radius is 2. So it will be pi 2 square by 2. That means pi r square by 2. And here radius is 2 because diameter is 4. In this case, it will be pi r square by 2 and here radius is 3 by 2 because here diameter is 3. So it will be pi 3 by 2 whole square divided by 2 because pi r square is the area of the circle, and if I divide by 2, it will be the area of the semicircle minus area of this semicircle. Here diameter is 5, so radius will be 5 by 2, so it will be pi by 2, 5 by 2 whole square. Since we are considering semicircle, so we have divided area of the circle by 2. In all the cases, we have written pi by 2. Now 2 and 4 can be cancelled. We got 2, so 3 2 ja 6 plus 2 2 ja 4, 4 by 2 pi, 4 by 2 pi plus 3 3 ja 9, 9 pi 2 and 2 2 ja 4 minus pi by 2, 5 5 ja 25, 2 2 ja 4. Now this 2 and 4 can be cancelled. We got 2 pi. So we got 6 plus 2 pi plus 9 pi by 8 minus 25 pi by 4 to ja 8. If I take LCM of 8, 8, here it is 1, here it is 1. So LCM will be 8. 8 divided by 1 is 8. 6 8 ja 48 plus 8 divided by 1, 8. 8 to ja 16 pi plus 8 divided by 8, 1, 1 into 9, 9 pi, minus 8 divided by 8, 1, 1 into 25, 25 pi. Now 48 plus 16 plus 9, 25 pi, minus 25 pi divided by 8. This 25 pi and 25 pi can be cancelled. So we are left with 48 by 8, and 48 by 8, that is 6. So 6 centimeter square is the area of the shaded region. I hope sum is clear. So what we have done, first of all, using Pythagoras theorem, we got this side. Then area of the triangle plus area of the semicircle plus this semicircle, area of the triangle plus area of this semicircle plus area of this semicircle we have calculated, and from this we have subtracted area of this semicircle. As a result, we got the area of the shaded region. I hope sum is clear. And that's all for today. In the next video, I'm going to start from question number 5. Okay, bye bye, take care and wait for the next video.